Hello, Liam here. For many years, reports of a highly classified aircraft have circulated around restricted military testing areas. These accounts have often referred to a platform whose existence remained uncertain. However, the aircraft designated F-47 is no longer considered speculative. It represents a key component of the future structure of air dominance. In this episode of the Infographics Show, we will review the available information and examine the reasons behind its limited public disclosure. In March 2025, the United States awarded a major defense contract connected to the Next Generation Air Dominance Initiative. One of the primary outcomes of this program is the F-47 platform. Rather than serving only as a replacement for the F-22 Raptor, the aircraft is intended to function as the central element of a broader operational system designed to exceed the capabilities associated with fifth-generation fighters. Current planning indicates that the U.S. Air Force intends to procure at least 185 aircraft, while development expenditures have already exceeded $20 billion. One of the defining characteristics of the F-47 is its projected performance envelope. The aircraft is designed to achieve speeds exceeding Mach 2, equivalent to more than 1,500 miles per hour. Although precise figures remain classified, some reports suggest a potential speed of max 2.25, or over 1,500 miles per hour. Speed, however, represents only one aspect of the platform's overall design considerations. The aircraft is expected to operate at ranges exceeding 1,000 nautical miles into combat zones without aerial refueling. This represents a significant change in operational capability. Such range enables the F-47 to penetrate deep into contested airspace and maintain a presence for extended periods. This capability is particularly relevant in regions such as the Pacific, where operational theaters are separated by large expanses of ocean extending thousands of miles. In terms of physical design, the aircraft is also considerably larger than most conventional fighter platforms. Its structure incorporates advanced carbon fiber composite materials, which provide high structural strength while remaining significantly lighter than traditional metal alloys. The combination of reduced weight and increased structural integrity allows the aircraft to carry larger fuel reserves than previous fighter designs, thereby extending both operational range and mission endurance. As a result, the platform is capable of traveling substantial distances without interruption. Many fifth-generation aircraft require multiple refueling operations during missions of comparable length. By contrast, the endurance profile associated with the F-47 allows it to patrol extensive maritime regions, maintain surveillance over naval formations, or remain positioned above strategically important areas for prolonged periods without reliance on aerial tankers. This capability provides a level of operational flexibility that has not previously been available in fighter aviation. An F-47 could operate deep within the Pacific theater while still maintaining substantial fuel reserves, whereas other long-range fighter platforms may already be accounting for return. In operational environments characterized by large geographic distances, endurance becomes a critical factor influencing overall mission effectiveness. When extended range is combined with high-speed performance, the result is not only improved mobility, but also a meaningful shift in operational dynamics. Speed in this context is not merely a performance metric, it directly affects response time, survivability, and tactical positioning within contested airspace. A significant technological development supporting this capability is found in the aircraft's engine architecture. The F-47 incorporates a three-stream adaptive propulsion system, capable of modifying its operating configuration during flight. In one configuration, the engine prioritizes maximum thrust, enabling high-speed performance. In another mode, it adjusts airflow distribution to emphasize fuel efficiency. The additional airstream also performs a critical thermal management function, absorbing heat generated by onboard systems, reducing the aircraft's thermal signature. Another anticipated capability is sustained supersonic flight without the use of afterburners, referred to as supercruise. This allows the aircraft to travel faster than sound without relying on afterburners, thereby reducing fuel consumption and limiting the infrared emissions associated with high-thrust operation. Reports indicate that experimental prototypes have been undergoing testing since approximately 2020, while the first officially acknowledged flight is projected for 2028. Operational deployment is currently anticipated for the early 2030s. The combination of sustained supersonic flight and long-range endurance introduces a new set of possibilities. In geographically dispersed environments such as Pacific Island regions, or during rapid response missions in European theaters, the aircraft could reach contested airspace before opposing forces. The integration of high speed and extended endurance creates a platform capable of maintaining a strong operational presence. However, performance alone is not sufficient. For this reason, the stealth architecture of the F-47 is designed to reduce detectability across multiple sensor domains. This approach enables it to operate within highly defended airspace. The design philosophy of the F-47 reflects a shift in priorities compared with earlier fighter aircraft. Rather than focusing on traditional close-range maneuvering engagements, the platform emphasizes range, persistence, and low observability. This allows the aircraft to maintain a position for extended periods, engaging targets when parameters are optimal. The cockpit environment incorporates a large integrated digital display system designed to present a wide range of operational information within a unified interface. Sensor data, aircraft status, and external battlefield information can be displayed simultaneously, allowing the pilot to maintain situational awareness across large distances. In addition, onboard computing systems assist with rapid data processing and decision support, enabling the pilot to concentrate more directly on mission execution. Structurally, the aircraft is engineered to tolerate high aerodynamic loads during maneuvering. Advanced flight control software continuously monitors aircraft behavior and automatically adjusts control surfaces and power settings to maintain stability and precision throughout flight operations. The F-47 program represents a significant long-term investment. Its development integrates advanced propulsion, sensor fusion, and survivability technologies intended for several decades. Among these features is a stealth architecture that incorporates engineered materials designed to reduce radar detectability, contributing to a lower radar cross-section. The aircraft is also expected to feature reduced infrared emissions, which decreases the likelihood of detection by heat-seeking sensors used in modern missile systems. Multiple design elements contribute to this effect. Even the cockpit canopy is treated with a specialized metallic coating intended to limit electromagnetic reflection. The external geometry of the aircraft has been carefully shaped so that surfaces and contours minimize the reflection of radar energy back toward emitting sources. When radar systems scan the airspace, conventional aircraft generate detectable reflections. By contrast, the radar signature of the F-47 is expected to be smaller than that of the F-22. The design reflects a broader effort to redefine survivability. The F-47 is expected to incorporate thermal management systems that regulate exhaust temperature before it exits. In addition to passive stealth, the aircraft may employ electronic countermeasure systems capable of interfering with hostile radar signals, generating misleading responses. Despite these defensive capabilities, the platform also maintains a strong emphasis on offensive capability, with stealth designed to support effective weapons deployment. Some reports suggest that the F-47 may be capable of carrying up to 12 air-to-air missiles within internal weapons bays. Internal storage is an important design feature. By housing armaments inside the fuselage, the aircraft is able to maintain its low observable profile during combat operations. The integrated computing systems manage sensor inputs. Radar systems, infrared detectors, and surveillance instruments provide data that contributes to a comprehensive situational awareness capability. These systems represent a substantial development. Rather than functioning as isolated instruments, the aircraft's sensors operate within a unified data network that continuously evaluates information and identifies threats. This level of integration enables the aircraft to respond rapidly. For example, if a surface-to-air missile is detected, systems evaluate evasive maneuvers or offensive options. These calculations are performed within fractions of a second, providing the pilot with immediate and prioritized operational guidance. The F-47 is a highly integrated platform. One of the primary weapons is expected to be the AIM-260 missile. This missile is estimated to have a range of 120 miles and reach speeds approaching 5 times the speed of sound. At such velocities, opposing aircraft may have limited time to detect and respond. High-speed weapons present challenges even for advanced air defense systems. The F-47 is expected to support long-range precision strike missions. These operations involve engaging high-value targets like command facilities while remaining outside defensive range. Through advanced targeting and sensors, a single aircraft could potentially engage multiple geographically separated targets during a single mission. Potential integration of hypersonic munitions, which are engineered to reduce the likelihood of interception and reach targets rapidly. Supporting this is a centralized computing system that processes targeting data. In addition to conventional weapons, some analyses suggest the F-47 could potentially incorporate directed energy technology, like high-energy laser devices. Directed energy systems provide defensive advantages. A laser could disrupt sensors or guidance on incoming munitions at the speed of light, with a significantly shorter response time. The internal weapons bays are expected to feature a modular configuration, allowing mission planners to adapt payloads to specific operational requirements like interception or deep penetration. The F-47 contributes to the high level of confidentiality. Rather than just a fighter, the platform is expected to operate as an integrated command and control node. Another feature is the use of collaborative unmanned aircraft, referred to as loyal wingman systems. A pilot could coordinate and direct multiple supporting drones. Each additional unmanned aircraft contributes extra sensing capability and weapons capacity, increasing the overall operational effectiveness of the F-47 system. While conventional air defenses respond to a few aircraft, a coordinated group of unmanned platforms from multiple directions presents a significantly more complex challenge. Coordination is managed through advanced onboard computing and secure communication links, allowing a single pilot to direct a networked combat formation. The development of the F-47 is associated with a longer technological history. For years, observers reported sightings of unusual tailless aircraft near Area 51. Elements of design can be traced to earlier research, including the X-36 developed in the 1990s. It demonstrated controlled flight without traditional vertical tail fins. Concepts explored in those earlier experiments appeared to have influenced later design approaches used in advanced stealth aircraft. A large portion remains classified. Despite occasional official statements, much is classified. Estimated production costs for each aircraft are often cited in the range of $300 to $400 million US. Beyond technical specs, the program illustrates the continuing emphasis on maintaining long-term air superiority through advanced aerospace development. At present, the F-47 remains one of the least publicly understood aircraft programs, with many technical details restricted to classified environments, accessible only to a limited group of specialists involved in its development. If you enjoyed this briefing, subscribe and hit that hype button. Tell me in the comments what you think.